So I think naturally, we don't always like to look at like one set value. It's nice to link some values together. So we're looking at cumulative binomial probabilities, right? More than one probability linked together. So this is the table of the probability distribution for the blood type. So remember there were 5 children, right? And we want to see how many have type O blood. So again, uh, no children out of the 5 could have type O blood, or all 5 children. You see the probabilities there. Again, notice that around 1 and 2, there's the most, right? It's very, very rare that all 5 would. So say we wanted to find the probability of at most one child having type O blood. So that means that 1 is the highest, but it also could be less than 1. So this is the interpretation, probability of x less than or equal to 1. But notice you need to use both of those probabilities. You'd have to add this probability and this probability. And again, when I circle that, I really should just circle the probabilities, right? These two numbers added together would give you the probability of having at most one child. Down here, we're using the words at least 2. So when we say at least, that means 2 is the smallest, but we can be bigger. So notice the notation greater than or equal to 2. And notice we're using 2, 3, 4, and 5, all of these. Okay, so these 4 numbers. And again, remember, you can use the idea of 1 minus to help you. So in the second example, we could add these 4 together, or we could also take 1 minus and we could add those 2. Right, so we could add the 2 that we're not including and then subtract from 1, because remember, all 6 of those probabilities have to add up to 1. So be aware of that. So there's multiple ways to do problems. Again, it's just, how many numbers you want to type in your calculator. Not a big deal. Okay. All right, so let's take a look at an example here. So this is, again, will Patty pass the pop quiz? So let x equal the number of correct answers that a student gets on the pop quiz. The probability distribution of x is shown here. Patty is one of the students in this class. Find the probability that Patty gets more than 2 correct answers on the quiz, right? So she wants more than 2. That is strictly more than 2. So we want to find the probability of x being more than 2, right? Notice there's no equal sign, though this does not include 2. So this would be the probability of x equals 3 plus the probability of x equals 4 plus ... all the way to the probability of x equals 10. I would have to add 1, 2, 3, 4, 5, 6, 7, 8 numbers. That's not fun. So why don't we do this instead? Let's do 1 minus, and let's add these 3 probabilities up, right? The probability of x equaling 0 plus the probability of x equaling 1 plus the probability of x equaling 2. And let's add those and then subtract that number from 1. How about we do that? Okay. All right, so let me take a picture of this. So I have those 3 numbers. They are kind of obscure. Okay. All right, so let me go into Desmos graphing calculator. And again, I'm going to take 1 minus, and again, I'll use the parentheses. And now I'm going to add 0.1074 plus 0.2684 plus 0.3020. And there is the probability that she's going to get more than 2 correct. 0.3222. And we'll just leave it at that. Okay. So again, if we come back here, because I really didn't write it out, so let me just write it out real fast, I hope. Okay, so again, that would be 1 minus, and we added 0.1074 plus 0.2684 plus 0.3020, right? We added those 3 up and subtraction from 1 and got 0.3222. Okay, so again, it's just, again, however you want to do the problem, long way or short way. It's up to you. All right, objective 3 is coming up next.